Before I show you the product, let me start with the problem we're trying to solve. Today, there's a huge amount of XRP that could be used within the Flare ecosystem through FXRP. But if you look at the organizations that actually hold large amounts of capital, banks, asset managers, regulated exchanges, institutional funds, most of them are still hesitant to participate. And it's not because they don't like blockchain technology. The issue is compliance. Before these institutions can interact with an asset, they need to make sure it's not connected to sanctioned entities, money laundering, ransomware groups, or other illicit activity. But public blockchains create a second problem. If an institution performs those compliance checks openly, it can unintentionally reveal client relationships, trading activity, or sensitive business information. So they're stuck between two requirements: staying compliant while protecting privacy. That's exactly why I built AegisFlow. AegisFlow acts as a private compliance layer in front of FXRP. Before an XRP address can mint FXRP, it is screened against sanctions lists and high-risk wallet databases. But instead of running those checks on a traditional server, the screening happens inside a trusted execution environment. That means the verification remains private, while the outcome can still be independently verified. It's much easier to understand when you see it in action, so let's jump into the demo. I'm going to start with a normal address. I'll click the example address and hit Verify. A few seconds later, we get the result: clear. This address doesn't appear on any of the monitored sanctions or risk lists. What's important here isn't just the verdict, it's how the verdict was produced. The address was sent into the secure enclave, the compliance checks were performed inside that protected environment, and only the result came back out. Nobody can see the screening process itself. For institutions that need to verify thousands of addresses while protecting client confidentiality, that's a critical requirement. Now, let's try something more interesting. This address is actually listed on the US Treasury's OFAC sanctions list. I'll run the exact same verification process. This time, the result is blocked. And this isn't mock data. The system uses real compliance datasets, including OFAC sanctions, wallets associated with North Korean cybercrime groups, ransomware operators, and several other public risk databases. In total, the platform currently monitors roughly 12,000 known high-risk wallets. But a compliance verdict isn't very useful if nothing happens afterwards. The real question is whether the system can actually enforce the decision. So let's request 100 FXRP for the address that passed screening. The transaction succeeds. We can open the transaction on the Costin2 Explorer and verify that the minting process completed successfully. Now let's repeat the exact same process with the sanctioned address. Same amount, same workflow. But this time, the request is rejected. No FXRP is minted. And more importantly, that decision is enforced directly by the smart contract itself. This isn't just a warning message that someone can choose to ignore. The protocol physically prevents sanctioned wallets from receiving FXRP. The next question is, how do you know any of this is legitimate? That's where the proof layer comes in. This page contains the on-chain transactions, the verification records, and the corresponding Flare data connector voting round used during validation. Independent data providers participate in reaching consensus on the outcome. And on the privacy side, the screening logic runs inside an Intel SGX enclave hosted through Phala Network. The enclave loads its code directly from the public GitHub repository, so anyone can inspect the source code and verify that the code being executed is exactly the code that's publicly available. And while this demo focuses on FXRP, the idea goes much further. AegisFlow implements the ERC 3643 standard, which is widely used for compliant and regulated digital assets. That means the same infrastructure can be used by tokenized funds, regulated stablecoins, real-world asset platforms, security tokens, and many other institutional-grade products. So, to summarize, AegisFlow enables institutions to participate in decentralized finance without compromising compliance requirements or client privacy. Compliance that can be verified, privacy that can be preserved, and a practical path for bringing more institutional capital into the Flare ecosystem. Thank you for watching.